Hello everyone, welcome to our class. Today, we will begin with the first method for handling pipeline leakage, replacing gaskets when a flange on a pipeline leaks. We can choose to replace the gasket or use leak sealing to resolve the leakage issue. Replacing the gasket is relatively simple and suitable for most pipeline leakage situations. When a gasket on a valve or equipment flange connection on a bypass pipeline is damaged and leaking, the gasket can be directly replaced by disassembling the flange after switching the process. When a gasket on a main pipeline flange connection is damaged and leaking, the gasket replacement must be performed under the condition of temporarily stopping the local pipeline network. When disassembling the leaking flange, it is necessary to ensure power is off, isolation is in place, and work indication signs are set up. During the disassembly of the flange, pay attention to collecting any accumulated liquid, and start by removing the bolts farthest from you to ensure safety. The following is an introduction of replacing gasket on a bypass pipeline valve. First, before installation, check whether the flange type meets the requirements, whether the sealing surface roughness is qualified, and whether there are any mechanical damages, radial scratches or corrosion. Second, check whether the material type and dimensions of the bolts and nuts meet the requirements. The nuts should rotate freely on the bolts without wobbling. The threads should not have any breaks. The bolts should not be bent. Third, check whether the material type and dimensions of the gasket meet the requirements, and whether it matches the flange sealing surface. The gasket surface should not have any mechanical damages, radial scratches, severe corrosion, or damage to the inner and outer edges. Fourth, before installing oval or octagonal cross-section metal gaskets, check whether the cross-sectional dimensions of the gasket match the trapezoidal groove dimensions of the flange, and whether the groove surface roughness meets the requirements. Fifth, before installing the gasket, check that the pipeline and flange do not have installation quality issues such as misalignment gaps or misaligned holes. The two flanges must be on the same center line and parallel. Do not use bolts or pointed steel drill rods inserted into the bolt holes to correct the flange, as this may cause the bolts to bear excessive shear stress. Only one gasket is allowed between the two flanges. Do not use additional gaskets to compensate for excessive gaps between the flanges. Sixth, the gasket must be installed accurately to ensure even pressure distribution. Seventh, to prevent asbestos rubber packing gasket sticking to the flange sealing surface and making cleaning difficult, you can apply a thin layer of graphite coating evenly on both sides of the gasket. The graphite can be mixed with a small amount of glycerin or machine oil. Metal-clad gaskets and spiral wound gaskets do not require graphite powder. Eighth, select bolts of appropriate length. First, insert 3 bolts into the corresponding flange holes. Then install the gasket and finally install the last bolt. Tighten the 4 sets of bolts and nuts by hand first. During the operation, note that if single-end bolts are used, the bolt orientation should be consistent. If double-end bolts are used, Ensure that each end of the bolt extends 1 to 2 pitches after the nut is tightened. After hand tightening, use a wrench and a box end wrench to tighten the bolts diagonally to ensure the flange surface is even. Finally, after installation, check that the flange surface is flat and there is no misalignment. Next, let's watch a video of the gasket replacement operation. While watching, please actively think about the aspects that need attention during the operation.
Pipe gasket replacement. Operators detected a leak during patrol inspection. Upon examination, the leak was found at the flange gasket at position A, requiring replacement of the flange gasket at position A. First, preparation. First, prepare the necessary supplies for maintenance work. Maintenance notice board, soapy water, quick hose, tags, open-end wrench, box-end wrench, new gasket, and so on. Place the maintenance notice board at a prominent location near the maintenance site. Second, lockout and tagout. Confirm that inlet valves V1 and V6 are closed and the power supply is turned off. Implement lockout and tagout on the power supply. Third, drainage and pressure relief. Connect one end of the quick hose to the drain valve at the lower part of the pipeline. If the liquid is flammable and prone to static accumulation, the container must be grounded during discharge. The other end is placed in the drainage ditch. Since the material here is water, it can be directly discharged into the drainage ditch. If the material is a chemical, it must be discharged into a designated container. Open V8, V9, or V11 to drain residual liquid from the pipeline, ensuring that 2 discharge ports are used simultaneously for pressure relief and drainage. Fourth, purge. Connect the hose to compressed air to purge the pipeline. Fifth, pipeline isolation. Isolate the pipeline. Dismantle the flange at B1. Note to use the box end wrench in conjunction with the open end wrench. First, loosen the nut farthest from yourself. Remove 1 bolt. Loosen 3 bolts. Flip the blind flange and reconnect the flange plates. Ensure bolts are tightened diagonally. Dismantle the flange at B2. Remove 1 bolt. Loosen 3 bolts. Flip the blind flange and reconnect the flange plates. Ensure bolts are tightened diagonally. Hang warning signs at the blind flanges of B1 and B2 respectively. Sixth, gasket replacement. Dismantle the flange at A. Take out the old gasket. Place the replaced old gasket at the designated location. Position the prepared new gasket at the center of the flange plate. And reconnect the flange at A. Ensure bolts are tightened diagonally when reconnecting the flange. Seventh, air tightness test. Check the valves of the pipeline to be tested for air tightness and close V6. Prepare a quick hose. Connect one end to the compressed air pipeline and the other end to the pipeline to be tested for air tightness. Open the compressed air control valve. To slowly pressurize the pipeline to 0.2 megapascals. The pressure must not be too high or too low. 8th, data recording. Record the pressure gauge reading every 2 minutes. 9th, soapy water leak test. Spray soapy water on positions A, B1, and B2. Observe for bubbles, and maintain stable pressure for at least 5 minutes. If bubbles appear or the pressure gauge reading changes, open V6 and V10 for pressure relief. Check for leak points. Eliminate the leakage, and repeat the air tightness test until no leakage occurs. 10th, pressure relief. Open V6 and V10 for pressure relief. Observe that the pressure gauge reading returns to 0. Only after ensuring complete pressure relief can the hose be disassembled. Never disassemble the hose under pressure. 11th, restore blind flanges at B1 and B2. 12th, remove tags. Remove tags from inlet valve V1, power supply, and blind flanges at B1 and B2. 13th, clean up the site. Return tools to their original positions and clean the work site.
Today, we learned about the gasket replacement operation. During the operation, personal protection must be ensured. When disassembling the bolts on the flange, start with the bolt farthest from you. When installing the flange, tighten the bolts diagonally. To ensure the flange is aligned and flat after installation, preventing any leakage.